The following is the video solution from JSDT Solutions. Question 7 says AB is a vertical flagpole that is the square root of 5 p meters long. And then AC and AD are two cables anchoring the flagpole. B, C, and D are in the same horizontal plane. And then we are also given that BD is 2p meters and ACX, this angle over here, that is X, and ADC, this angle over here, is 45 degrees. So the first question, 7.1, says, determine the length of AD in terms of P. So AD is over here, and we need to ensure that we relate it with some shape, okay, triangles clearly here, that includes AD. So that would be this right angle triangle over here. Normally with these questions, we would use trig ratios to solve for this, but please notice that this 45 degrees is not the angle measured here inside this triangle ABD. That's not that angle, okay? That is the angle measured for the outer triangle that we are seeing here, this bigger triangle. So what we can use to find AD would be, because we have been given this side, and this is a right angle triangle, we can simply use Pythagoras. So let's go ahead and do that. We would say that AD squared is equal to, and that is the hypotenuse, so the two shortest side and individually squared. So that is square root of 5 and then P all squared plus 2P all squared, and then this is equal to, we'll say AD squared is equal to, and when you square the root 5, it becomes 5, and we have P squared. When you square 2, it becomes 4, and P squared. So that would give us 9P squared. So AD equals 9P squared. Then to solve for AD, we can square root both hand sides. We don't have to consider the positive and negative solution because these are lengths, so they will always be positive. So this is 3P, and there we go. That is AD in terms of P. Question 7.2 says, show that the length of CD is equal to this. Okay, so we just need to find CD. So CD is over here, and looking at CD and the triangle that we're going to use to find CD, we need to use a triangle that would have dimensions available, like angles and sides. So using this one on the bottom is not a good idea right now because we don't even have any angles there. The only side we have is BC, and then that's about it. So let's focus on using this bigger triangle over here. So in this triangle, what can we use? Well, we've got two opposite dimensions, C, an angle over here, and a side that are complete. So since we're looking for CD, we could focus on finding this angle CAD first, since it is opposite CD, and then we could use the sine rule here. So how do we find this angle A, that CAD? We can find that because we have two angles in this larger triangle. Remember that the angles in a triangle add up to 180 degrees, so that angle CAD would be found by saying 180 degrees minus X minus 45 degrees. So angle CAD equals, we'll say 180 minus X minus 45 degrees, and this gives us, that's going to be 135 degrees minus X. Okay, so now that we have that angle, we can use the sine rule. So using the sine rule, because we are looking for a side, we can just start by saying CD over sine of the angle opposite, which is 135 degrees minus X. And then we'll say this is equal to AD over sine of the angle opposite AD, which is X. Okay, so that's what it's going to look like. But just remember, we already know the length of AD is 3P, so we can just say 3P. Okay, so this is what it looks like. So the only thing we need to simplify would be that sine 135 degrees minus X. So we have CD over, and let us just, you see that's 135 degrees. We can actually pull out a 90 degrees from that and then use cofunctions. So this is sine, and we can split that 135 degrees as 90 degrees plus 45 degrees. That's what gives you 135 minus X. And really what we're doing here is we're trying to group these two together as if they're one single angle and then apply cofunctions. Then this is equal to, we have 3p over sine x. And now let's just continue simplifying that. So we have CD over, and that becomes, you see, if you have sine 90 degrees plus an angle, it is equal to, the identity would be cos of that same angle. So this would become cos of 45 degrees minus x. Okay, and then at this point, we can focus on getting CD on its own. So we still have sine x here. And to get CD on its own, you can transpose cos 45 degrees minus x. In other words, multiply both hand sides by cos 45 degrees minus x. So this is CD is equal to, and we'll have 3p, and that got multiplied. So it moves here to the numerator, and it is cos 45 degrees minus x all over sine x. And we just have to simplify that because you see, that's not what it looks like over there. So let's go ahead and simplify. CD is equal to 3p, and we can use the compound angle identity for cos 45 degrees minus x, which is really cos A minus B. So that's going to become, they'll become two terms, so we'll put them in brackets. So it's going to become cos 45 degrees times cos x. Then because we have a minus, it changes to a plus. Sine 45 degrees sine x. And this goes all over sine x. Okay, so still simplifying that part. CD is equal to, we still have 3p multiplied by this cos 45 degrees. It is best to not use the calculator, because if you use the calculator, your answer will not look like theirs. And then you may end up panicking, thinking you've done something wrong. So you can either use the triangles for your special angles or the circle, that 2-unit circle that we use. But in this question, I'm going to use a rule called the OHA rule. So we start by saying OHA. So this is used for special angles. And then the angles we'll put down is 30 degrees, 60 degrees, and 45 degrees. Then we'll say 1, 2, 3, 3, 2, 1, and 1, 2, 1. Okay. And then in each row with the numbers, we're going to square root the biggest number. So here the biggest number would be 3. We square root. Here biggest number is 3. And then the largest number is 2. And this is how we're going to solve for these functions with special angles. Cos 45 degrees, right? Remember that from SOHCAHTOA, cos is adjacent over hypotenuse. So we'll go to the 45 degree row and we'll take the adjacent side, which is 1, over the hypotenuse, which is the square root of 2. So that becomes 1 over square root 2 multiplied by cos x. And you see that if you multiply these two together, because this is in the numerator, it really just becomes cos x over root 2. Then we'll say plus, and then sine 45 degrees. Sine is saw, opposite over hypotenuse. So go to the 45 degree row, and we say the opposite is 1 over the hypotenuse of square root 2. Same situation. 1 over root 2 is multiplying by sine x. So that just gives you sine x over root 2. And we can see their denominators are the same. So this still goes over sine x. At this point, you can even apply the sine x over here. So I'm going to take the 3p and divide by the sine x. So 3p over sine x. And you see there's a bracket in front of this. You see these two can just go together and you're still multiplying by all of this. So we're multiplying by these two because their denominators are the same. They can be written under the same denominator. So that is cos x plus sine x. Let's put it in their order. They said sine x plus cos x. So we can already start from there. And this goes all over the square root of 2. And so therefore, CD is equal to, and we're multiplying 3p with something that has 2 terms in the numerator. So make sure to put brackets. So that's going to be times sine x plus cos x all over, and sine x times root 2 is root 2 sine x. And that is our answer, just as they have it as well. Okay, and that is it for 7.2. Question 7.3 says, if it is further given that P is equal to 10 and X is equal to 110 degrees, calculate the area of triangle ADC. So let's look at that triangle. The area of triangle ADC. So this is this highlighted triangle over here. And they've given us the value of P and X. So we can clearly use the area rule in this case, because you can see that we don't really have a perpendicular height. That height has nothing to do with that triangle. It's not that triangle's height. So here is how we can use the area rule here. Let's take a simple looking angle. We already have this, and the sides we have AD and we have CD. So we can take those two sides and this angle. Remember the area of a triangle using the area rule. If you have a triangle ABC, you can say a half multiplied by AB multiplied by AC, and then sine of the angle in between those sides. So sine of angle A. And that's what we're going to use here. So this would be a half multiplied by AD multiplied by CD, and then sine of that center angle, which is 45 degrees. And then we'll just substitute AD and CD and then substitute the value of P and X. So this is equal to a half multiplied by AD is 3P. We already found that initially in the triangle 3P, and then AC as well. So this is just 3P, but we know what P is now. P is 10, so P times 10. And then CD is over here. So we'll just take this, and in place of P and X, just substitute the P and X values. So this looks like this. And in place of P, we'll just say that is 10. In place of X, we'll say that's 110, and that's 110. And then over sine of square root 2 sine of 110 degrees. So this just has to do with substituting. Then lastly, multiply by sine 45 degrees. So times sine 45 degrees. And let's put that on our calculator and find out the area. And there we go. This is our answer. This is finally equal to 143 points, and that rounds up to 11. And these were in meters, right? They actually said they were in meters. So that would be meters squared. And that is our answer. And that is it for question 7.